Okay, hopefully my screen is visible now. So I've discussed with this slide, then I move on to next. So yeah, so again, while connecting or charging a cylinder, necessary respirator or eye goggles should be worn. First, the cylinder valve should be closed, and also then the process header or valve will be disallow any gas to remain in between. So whenever you are handling or activating any headers or like that, you have to use the uh, goggles and also the necessary respirators if it is in a corrosives or any other harmful gases. Then for the emptying of the residual gases, so the cylinder should not be heated. So you see this kind of practices, especially in the roadside tiffin centers, even some of the hotels. So they used to keep the cylinder in the hot water, or sometimes they will change the position of the cylinder from vertical to horizontal to get the maximum amount of gas from the cylinder. Okay. Then provision of the gas cylinder rules or SMPV rules shall be followed. So whatever the rules and regulations as per the SMPV rules has to be followed. Now we'll see safe storage and handling of chlorine. So chlorine again, it is in a greenish yellowish gas. If you could have seen in case of any leakage happen, so basically it will have an yellow color gas, robic or rhomic crystals. Like I mean, the boiling point will be 34, and density is 1.47. Hence, it is denser than air, so it's always tends to settle down in the lower parts or pits or etc. The vapor pressure is 4,800 20 degrees centigrade. TLV is 1 ppm, STL is 3 ppm, and LC 50 is 15 ppm. Okay, 1 second. Okay, yeah. And addition toxicity, it poses a fire hazard as well. So when it react with uh, terpentine and even ammonium gas, hydrogen or powered metals, or polypropylene, wax or rubber, or acetaldehyde, even acetylene, alcohol, or many materials. When it is heated, emits toxic fumes. So whenever it is heated up, it releases toxic fumes. That's why we are not supposed to store toxic chemicals. We can't store this chlorine with the flammable materials. When it is reacted with water or steam, produce again toxic and corrosive fumes of uh, hydrogen chloride. Okay. Then employee selection and training. So when we talk about employee selection, it is as most important. Whoever is having experience and also who is handled such kind of chemicals, they'll be preferable to have to choose as an operator or a supervisor. So persons affected with asthma or bronchitis, and even chronic lung conditions, and also irritation of upper respiratory tract should not be employed where the exposure to chlorine might occur. So wherever there is a chance of exposure of chlorine, there you are not supposed to take any uh, people who have such kind of difficulties. Training classes for both the new and old employees should be conducted periodically to keep them conscious and informed of hazards. That is also very important. We have to conduct a regular training on this handling of chlorine, and they should be instructed and trained to adopt preventive measures in case of emergency and to use the safety equipment. And also, they should be trained on the adaptive measures. So, in case of any leakage happens, in case of any spillage happens, in case of any incident happens, how they can able to handle, and also emergency equipments also like leakage kits or other emergency situations. Then leakage tools. So these are also very important, especially when you are handling with chlorine. So we do not use water directing on leak. It is not supposed to be. So as we know that if you are using, it is interact with water, it can create the toxic fumes, and also you are not use as a jet at the near the leakage, so that it can have a chance to enter inside the cylinder. Keep emergency kits handy in proper working condition to control chlorine leakage, and also train workers in their use. So we should have emergency kits ready uh, and properly available, and also the workers or the people who are handling the chlorine or who is working in that premises, they should be well aware about handling of the emergency kits or leakage kits. Then appropriate facility for chlorine absorption through caustic soda or lime or soda ash solution should be established and also maintained in the event of leakage. So these will be the absorbing agents. So in case of any leakage happens, we can use these materials to absorb the leaked chlorine. And the container should not be immersed in the same absorption media. So this is not very important. So hence it is an absorbing medium. You should not go on the immerse, which means you can't put the cylinders in these solutions. The ammonia mortar used as a torch should be located the nearby places where the chlorine containers are generally received. The storage are used in the process as to facilitate easy detection and also any leakage of with fumes. So whenever this ammonium water, you dip a piece of cotton with a stick. So basically, we use the in Telugu we call it as a kagada. You can have a wooden stick with an cotton which is rolled at the end and dip in the ammonia water. Then when you take it to the near chlorine leakage, so it will give an a the white color fumes, so that you can understand there is a leakage. Even minor leaks also you can easily identify. So that's why we call it as a torch. And self-breathing apparatus, gas mask or emergency kits should be located at the strategic points and at the working condition, and to easily accessible in the event of emergency. So this is also important that we should have a breathing apparatus, SCBA sets, or readily available in case of any emergency. We can use them. Then storage area, so it should be cool, dry, and well ventilated, clean and protected from external heat sources, and it should be remote from elevators or gangways or ventilation systems. So it should be remote. So whenever we say remote chlorine, so from the elevators. So when you say elevators, it will have a chance to go to the elevator pits, even the gangways, or any ventilation systems. So why it is a ventilation system? Sometimes it will have the ventilation system may absorb. Ventilation system, if it means HVACs, where we'll take the fresh air, outdoor units. So there will be a chance of extraction of this leaked chlorine. That's why always this chlorine storage will be at the somewhere in the remotely in the facility. Then ventilation must be sufficient to prevent the accumulation of paper pockets, and all the fan switches should be outside the storage area. So when we say fan, the exhaust fans, as I shown you in the previous classes, so hence if the vapor density is higher than air, it will have tends to be on the floor or in the lower levels. So we'll have this exhaust and the floor level, so that it can able to suck immediately, then take it to the scrubber for the neutralizing. And as far as possible, the building of the storage and also chlorine should be entirely of non-combustible construction and separate from other building. So this is also important. It should be always have a separate building. You should not mix with the other buildings and also a non-combustible construction, which means fire rated buildings. In the case of storage, it is not a different building. It should be in the ground floor with at least two exits opening outside and also separate from the other parts of the building by fire resisting and all walls and also floors. So if it is not possible to have in a separate building, it should be in the ground floor. Why it is ground floor? Because of the vapor density. Okay. Now we'll see the tunnels. I mean, these are the chlorine tunnels. You could see how they look like. Then store chlorine cylinders upright and also rather secure them so that they cannot fall. For the small cylinders, we can have an upright, but big containers, we can have it in the horizontal position. The ton container should be stored in their sides and also rails of the few inches above the floor so that they should be stacked or racked more than one height. So wherever you have, they'll be stored on the rails so that it will be easy to handle. And also we can stock one on one. Keep enough space between the
Sir,
containers. All are accessible in the case of emergency. So for
sir,
each
what is torn containers?
tunnel, sorry,
What is torn containers?
torn containers in the sense the image which we have seen here. So there are close to 1 ton of capacity of chemical or chlorine we can store. It is in a heavy size of a cylinder, torn
Oh,
containers.
okay,
Yeah,
sir.
yeah, yeah. We should have maintain the access between, sometimes in case of any leakage between in multiple cylinders it will be difficulty to address on immediate basis. So it is always advisable to have or maintain certain gap between the cylinders for easy or accessible to uh, the leakage in the case of emergency. And store the containers in a converted shed only, that let them keep away from the hot sun or any other source of heat. So covered shed, it should not be stored on open atmosphere, so it should have a covered shed so that we can avoid the exposure to the sunlight. And do not store chlorine containers with explosives or acids or turpentine, either anhydrous ammonia, finally finely divided metals or any other flammable materials. These all types of materials are incompatible with chlorine. Then cylinder should be stored on a cement floor sloping towards a pit capable of collecting all the liquid in the cylinders. Under the no circumstances should water be allowed to run on to the uh, chlorine into the pit. So mostly will not allow them to, I mean, make a pit to collect such a huge amount of chlorine. Definitely will maintain the slope in the storage area. Okay. So with this, we done this topic. Meanwhile, I'll bring up the other presentation. If you have any questions, we can discuss. I'll just take a moment to bring the presentation up. Okay. Again, continuation of the same. So we have discussed this slide already. So do not store the containers in a wet and muddy area. So to avoid rust formation, use cylinders in order of their receipt, which is nothing but FIFO. Uh, Filled and also empty cylinders should be stored separately. Filled and empty cylinders. So it should have a dedicated space. And protective covers for the valve should be always be secured, and also even when the cylinders are empty, no oils or lubricant should be applied or used on the valves of the containers, and the correct tool should be used for the opening and closing of the valves. They should never be hammered. The valves should not be hammered at any case. In case of any damage, it can create a catastrophic accidents. The insulin should be never be lifted by the means of any metal cap. nor should be the rope slings, chains, or magnetic devices be used. The ton container should be handled within a suitable cradle with chain slings and combination with hoist or crane having at least 2 metric ton capacity. And never tamper with any the feasible plugs of the toners or apply heat to them. So feasible plugs in the sense, if you take pressure cookers in our home, we have two safety controls there. One is the whistle, which is act as a safety relief valve, and other there is a small knob which is adjacent to the vessel that is in the feasible plug. So basically, it will have a melting nature. So whenever the vessel is not activated, so at a certain temperature, instead of exploding the pressure vessel or cooker, it will melt itself. Then from there, the pressure can leave from the cooker. So that is kind of a setup. So for the down cylinders also will have the feasible plugs. We should not never tamper in the sense playing or hammering that feasible plugs, etc. We are not supposed to do. Then bulk storage. So this is another one. So whenever the compressed gas or any installation or tank vehicles used for the storage or transport of liquid or gases, the chlorine have to be approved and also licensed under the static mobile pressure vessel rules. Like that is nothing but SMPV rules 1981. An appropriate minimum safety distance as stipulated in the mentioned rules has to be maintained all in the buildings or groups. So in the SMPV rules, we'll have the safe distance between the tunnels and also distance from the other administrative buildings or production buildings. We'll see in the IS 105 paper. The tank has to be installed, entirely above ground, so it should not be on the underground. And the bulk storage tank for the chlorine should be installed near waste air systems. When you say near waste air systems, it is nothing but exhaust systems. So where it can connect it to the scrubbers. And at least two safety valves should be connected to the waste air systems. Then pressure indicators with alarm should be available in the control room. With this, uh, chlorine storage and emergency measures. So perforated pipes or connected to the blower suction around the storage tanks can be laid. In the case of any leakage, the leaked chlorine will be get sucked through this pipe, which leads to waste air systems when it can be neutralized. So in case of emergency uses, perforated pipes so that will not get reacted or coated ones. So where uh, a blower suctions in the sense where they take the air, they draw the air around the storage tanks. It's not only one side, around the storage area, so that we don't know, I mean, which side the leakage can occur. So it is always preferable to have around the area. We should have the pipes so that it can able to suck, then send it to the scrubbers. When I say waste air systems, nothing but scrubbing units. And safe bulk storage of chlorine call systematic inspection and maintenance. This is also very important. So if you're having the bulk storages, you should have regular inspections and also maintenance in place. Then through pipelines, if you're handling through pipelines, again piping dry chlorine and also materials of construction generally used is carbon steel. Piping arrangement should be simple as possible, and the number of screws of the flanges should be kept to the minimum so to handle it easily. And the piping system should be well supported and also adequately sloped to allow drainage, or low spot should be avoided. So it is nothing but it should have a proper slope so that it can be easily drained in case of any maintenance required. And suitable allowance should be provided for the pipe expansion due to the changes in the temperature, especially in the summers and winters. The expansion or the contraction will happen, so you should maintain some space or suitable allowance has to be given. Then cleaning may be accomplished by pulling through each length of the pipe a cloth of saturated with tri chloroethylene or other suitable chlorinated solvents, so that it can able to clean out the residual chlorine, so that then we can take for maintenance. Then emergency measures, again in case of a leakage or spillage, any person tackling of the chlorine should be equipped with emergency kits, self-breathing operators, mask, and also appropriate items of personal protection. In case of major leaks, all persons, including neighbors, depending on situation, should be warned and take the leaking cylinder and isolated open place, and also roll it in such a position so that the leaking point in the top. In the case of only gas and not liquid will escape. So what will happen? The liquid, it will be in liquid state. So if the liquid is leaking because of vapor density or expansion ratio, it can double the concentration or it will spread more. So we try to turn the cylinder in the leakage side so that only the gas can escape instead of in the liquid form. Then approach from the windward side so that the escaping gas can be carried downward to a lower levels. So no circumstances should water or other liquids to be directly towards the leaking container. And so the disappear gas, also water solubility of chlorine is more at low temperatures. It will be dissolved readily in the chilled water. So with you can use the chilled water to dissolve. Mostly we can use in the fog manner so that it can dissolve at the low temperatures, not at the high temperatures. And also we should be always in the uh, high wind direction. I mean windward direction in the sense highway, high wind direction, so that in downwind direction the chlorine will go. And also in case required, the evacuation also has to be done for the nearby villages or nearby occupants or the social people. In the case of large leaks, try to stop the flow of the liquid by closing the valves. So this is also important. And after containing the liquids, one can be uh, fluoroprotein foam to prevent the evaporation of the liquid. So this fluoroprotein foam, it is act as a barrier between the external heat and the liquid so that it can sustain the or it can avoid the uh, evaporation of the liquid, like how we use the foam uh, to extinguish the fire. Same way this foam can help us to avoid the evaporation of the liquid. In the case of large leakage, the alternate solution is to absorb the chlorine in an alkaline medium such as caustic soda, or also lime slurry. So these are the other alternatives we have seen in our previous slide. Also can also absorb the leaked chlorine. Now we'll see handling of ammonia. So again here, so the properties of ammonia, it is again going to be in a color and also pungent smell, like in a rotted egg smell. And melting point is -77, boiling point is 33. Sorry, 77, boiling point is 33 degrees. LEL is 16 and UL is 25. So density is 0.7 grams per liter, and vapor pressure is 10 at 25 degrees centigrade. Vapor density is 0.6 and TLV is 25 ppm. STL is 35 ppm. Okay. So basically, it is an irritant gas, and the fire hazard is low. Explosion hazards moderate. When exposed to flame, when it is heated, emits toxic fumes. To fight with the fire, stop the valve of the gas, then you can do it. When you say LE and UL, so as I said previously, so this is the fire point. So the lower exposure limit is the percentage of the ammonium in the atmosphere, 16. So within this, from 16 to 25, it can able to catch fire. If the concentration of the ammonium, which is more than UEL or less than LEL, it will not participate in the fire. Then ppm 25 TLV will calculate for 8 hours, STL 15 minutes. IDLH, it is not even for one breath. Then LD50, so LC50, through nose inhalation, we have discussed many times. LD through oral skin. Okay. Then general preventive measures. So designing of layout of area with an due consideration of adequate natural or mechanical ventilation. Then use of properly selected material for construction of plant and also equipments for handling of ammonia. Then preventive maintenance of all equipments is in proper working condition. We have to ensure that all the equipments are in a proper working order. Then avoid the contact of ammonia with certain other chemicals includes mercury, chlorine, iodine, bromine, calcium, silver oxide, or hypochlorite. So you're telling ammonia is supposed to be used, but for uh, leak detection we are using ammonium. So because hence they react each other, it can easy to identify the leakage. That's why we use ammonium as in a torch, but it should not mix together. Then first aid measures. So we have to keep trained first aiders who is having knowledge in the case of use of first aid equipments. Then provide necessary showers or eye baths and also oxygen administrative apparatus in the first aid centers. Suitable notices should be fixed in the convenient places regarding the first aid measures. So notices in the sense the instructions for the first aid treatment. Then PPEs, personal protective equipment. So we have to provide adequate and suitable protective equipments at all the times. Gas tight chemical goggles, self-contained breathing apparatus, then positive pressure hose masks, and also airline mask, chemical cartridge respirators, and hard hats, soft brimmed hats or any caps, safety toe, rubber boots or rubber gloves, etc. Whichever is suitable, we have to use. Then leakage tools. So use of large volumes of water directing on the leak. So in the chlorine case, it is an opposite. Here we can use the large volume of water directing the leak so that we can able to dilute. Then leak of ammonia should be searched for the preferably with the hydrochloric acid solution with a small cylinder of a compressed SO gas, or because of fire risk, sulfur candle should not be used. Gas mask should be located and strategic points under the working condition and to be easily accessible in the event of emergency. So some PPEs we always advise to have dedicatedly for the emergency situations. It is very important because the regularly used PPs will be available, but still it is always advisable to have certain quantities of PPs we can store for the emergency handling. Then storage and handling controls. So indoor storage should be cool, dry, and also well ventilated and protected from heat sources. And the building protected with automatic sprinklers, Weber tight electrical equipments, and good natural ventilation, good floor drainage, and adequate exposition venting should be required if you are storing in a indoor. Then outdoor, the location should be away from the flammable liquid storages. So that is the one key requirement. Then bulk storages. In the case of multiple storage facilities, a plant should be prepared for readily and also definitely approaching all the shut-off valves to be used by for isolating the various parts of the storage facilities. And each storage area should be protected at least 1 hour. A standard uh, fire hydrant, and also fire rated structure. Then gauge of the glass should be provided with an access flow check valves, and also the glass should not be longer than 120 centimeters and more than 60 centimeters between the supports. So this the gauge glasses we can use in between the pipes to see the flow of the ammonium. And storage tank construction should be integrity and also double wall type, known as a tank in tank. So you should have double wall, you will have a tank inside, and over that you will have the concrete structure. Each storage tank shall be equipped with two relief valves mounted on the three-way the hand valve to provide means of repair of the faulty valves, the three-way connection, so that we can able to bypass the faulty valves, and install remote controlled valves and also bottom of ammonium storage tanks so that we can able to control them remotely. And facilities for creating water curtains around the ammonium tank should be created to absorb ammonia vapors in the case of leakage. Leakage out, however, care should be taken not to add water to the liquid ammonia, else it will worse the situation. So it can we can absorb the, or we can dilute the ammonium with the water spray, but it should not mix with the water, with the liquids. The vapors can be suppressed. It should not mix with the liquids. It can react. Non-refrigerated ammonia shall be stored in a gas-tight containers, and in the event of power failure, provision should be made to run the holding compressor or all the ammonium storage by emergency diesel generating sets as to compress the excess vapors into liquids or ammonia. And a flare stack should be provided or burn ammonia vapor in the case of safety valves fails to release the ammonium pressure. So flare stack, the flare is nothing but where we use uh, to burn off the excess, the volumes or the leaks or the process vapors, so that it is in a safe release. Otherwise, if you are not burning off, those can create the vapor clouds in the atmosphere. Then we'll see handling of LPG. So chlorine LPG is the third chemical or major chemical which they use in the industries after chlorine ammonia, that is liquefied petroleum gas. As an LPG is a combination of propane and butane, or widely used as an fuels. And LNG, liquefied natural gases, is mainly methane. It is also stored as in a liquid as a transmission by high pressure pipelines for the industrial and domestic usages. Even natural gas liquids are mainly ethane, propane, and butane. They also transmitted by pipes. Fire and explosion are the main hazards associated with them, with the boiling points, and also the explosive limits of any hydrocarbons are under the limit. Okay, we should able to handle properly. So these are the properties and hazards of LPG. So boiling points and LEL and ULs, propane, butane, methane, ethane and ethylene and propylene. You can refer this later. Then a commercial butane, also called as N-butane, and propane are used as an LPG. They exist as an gases in the ambient condition, but they can be liquefied under the little pressure, and also release of this pressure, they again become gases. So under the pressure, they can change their state to liquids. Once the pressure releases, again they can come back to the gaseous state. As a liquid density is zero point 0.5, so will float on and vaporize on the water surfaces, and therefore the water is not in a good extinguishing media for LPG to fight with, and also keep cool the vessels. Its vapor density is 1.5 and does not disperse easily. It tends to sink to the lowest possible levels, and if it is ignited in the confined spaces. So as we discussed, whichever the gases or liquids which will have a vapor density is higher than air, they always tends to settle in the as low as possible, in the lowest levels, so that they creates in a confined space explosions. Okay, it can be explored also even The bottom ventilation holes near the LPG cylinders allows leaking gas to go outside. The explosive range is 2 to 10%. The flame can travel back to the source of ignition flashback. It can cause cold burns to sink due to the rapid vaporization or lower temperatures. When you say cold burns, even if you see the LPG cylinders in the bottom, it will be very cold. Even if you have chance to operate in a seawater fire extinguisher, also, it can form an ice near the hose or discharge hose. While coming out rapidly, it will have a freezing effect. It can create a cold burns. Okay, but time being, I'm stopping here now. We have just 5 seconds. We can continue in the next.